Hi, this is Ambika, Assistant Professor, Department of AIML. Let us discuss about verification and validation. So before that, we go for a small recap. So if the software has some bugs, means it won't work well, right? So if it has no bugs, but even in that case, it is doing some wrong task, whether we are going to check whether it is successful or not. So here, the reason is that we are going for the verification and validation, which ensures the correctness and the fitness. So what do you mean by verification and validation, and why we are going for the verification and validation? So we are going for the verification and validation because of the following reasons. In order to detect the defects early, it reduces the rework cost and also improves the reliability and safety. So here what do you mean by reliability? It is nothing but the software will run without any errors at least for a specific period of time. Then we should also ensure the user satisfaction, and the software should be built using some meeting some regulatory standards like policies or practices of the organization. So what is verification? It is nothing but we are just verifying whether we are building the product right or not. So it ensures the software it is built correctly according to the specifications. That is, it should conform to the requirements specifications, and it also follows some static techniques. There is no execution of the code, and this verification is done during the development phase. So let us see some verification activities. So verification is nothing but static. That is, as I told you earlier, there is no code execution. So some of the following needs we are going to follow, like requirements verification. So we will be verifying some requirements which we are getting from the users. That is, we are checking whether the requirement specifications are accurate, complete, consistent, and also feasible before development begins. Next comes the design reviews. So after gathering the requirements from the user and analyzing the users requirements, we are going for the design. So it also includes the architecture design, low level design, high level design, like that. So we are evaluating the architectural designs and also higher low level designs, and we are verifying whether they are meeting the user requirements or not, and some best practices has been followed or not. Next, the code review. It comes under the implementation. That is, the source code will be written for building the software, and peer reviews will be conducted to check whether we are following the programming standards and it is easy for readability, and also we are checking for some logical errors. Next, the verification activities, it also includes the static analysis. It is nothing but no code execution. Just we are utilizing some tools to analyze the code without executing them. That is, we are identifying whether the bugs are not are there or not, some security vulnerabilities are there, and whether they are following some standards or not. Next, the walkthrough. Some structured walkthroughs will be constructed to identify whether the developers they are presenting the code and whether any defects are there or not. Next one is inspections. Some formal inspections will be done, and also some checklist driven meetings will be conducted to evaluate the work our products, as well as it is nothing but it includes either maybe documents or code, and we are checking for the errors. Next one is validation activities. Validation is nothing but whether we are building the right product or not. There are some testing things like it starts from the unit test. So once a module is executed, we are going for the unit test. So if you are executing both the two modules like that, these two modules will be integrated and integration testing will be conducted. Next comes the system testing. So it is nothing but testing the complete integrated systems to check whether the requirements has been met or not. Next one is functional testing. So here we are verifying whether the software they are working correctly or not according to the functional requirements. Next one is acceptance testing. That is, it may be the alpha, beta, or user acceptance testing. That is, so after the completion of building the software, it is a formal testing which will be done by the end users, and they will check whether their requirements has been met or not, and also the business requirements has been met or not before deploying the software. Next one is performance or load testing. So it is nothing but assessing the responsiveness of the system and also the stability of the workloads. Next one is usability testing. So it evaluates how easily the user they can interact with the system. Next one is security testing. So it ensures whether the software is secure or not, and also it protects against the unauthorized access of the users. Next one is verification and validation in the SDLC lifecycle. So in requirement phase, this validation of requirements and verification will be done through the reviews. In design phase, the verification will be done using the models and inspections. So in implementation phase, we will be verifying the code, and as well as unit testing will be done here. Next one is testing phase. So here full validation will be done using the system testing as well as the acceptance testing. In maintenance phase, we will be using the regression testing and also the re-verification will be performed. Next one's techniques and methods. Here we will be following some techniques like black box testing. It is mainly done based on the functionality. White box testing will be based on the internal structure of the testing. Boundary value analysis, it focuses on the minimum value, maximum value, just before, just after, like that. Equivalence partitioning. Equivalence partitioning is nothing but here the input data will be divided into valid and invalid partisans and the test will be performed. Model-based testing will be done based on the abstract models and it will automatically generate the use cases. Next one is verification and validation in dependable systems. So it will ensure the safety, reliability as well as the availability in the dependable systems by using some formal methods, rigorous testing. So the common applications here are aerospace, medical devices, banking systems and embedded AI systems. So here the little comparison of verification and validation. So verification is nothing but whether we are building the right product. Validation is nothing but whether the right product has been built. In case of verification, it is static testing and validation is a dynamic testing. So mainly the verification, it focuses on specification, validation on conformance to the user needs. And the reviews will be conducted during the verification and testing will be done during the validation. And some advanced techniques will be formal verification, model-based testing, regression testing, as well as the automated testing tools. Thank you.